I have the Napari app open, and it's a basic interface. Here you can see it's to drag your image. You can just drag it onto this page. I'm going to open. I have a folder of sample images. We also have some sample images available on our website through either the Self-Feature Explorer or through our GitHub page that has the Napari segmenter, which I'll show you at the end of this. So here I'm going to, we've got a couple sample images. Today I'm going to show you Sec61B, which is the ER. So I'm just going to drag, if I can. The most complicated part is to drag this. Not really, but I'm just joking. Hold on. Why is it doing that? It's some like sort of Zoom thing. Here we go. All right. Great. Okay. So I drag that into my window, and here it pops up. You might not see anything, but here is a scroll bar at the bottom where you can scroll through your image and see this is so Sec61 is one of our tag lines. It tags the endoplasmic reticulum, and so here I'm just showing a Z-stack, a 3D image of this here. And so now I've dragged in my image and I want to open the plugin. So if you go up to the top of your window, up to plugins, you can choose to install or uninstall plugins. I actually have the Napari Allen cell segmenter already installed, but if you were to go in here, you can see which plugins you have installed, and you can see some other available plugins that they offer. All right, so since I already have this installed, for the sake of time, I can now go back up here. And now what I can do is you have basically two parts in the plugin. So if I go down here and I select Napari Allen cell segmenter, you can see two parts: Napari Allen cell segmenter workflow editor or batch processing. The workflow editor will allow a user to adjust the parameters in the existing workflows that are seen in the lookup table. So each workflow can be optimized based on the user's data. And we also have a way to save that workflow so that if you want to apply it to a large batch of files, you can use the batch processing, which is this one here. And that'll allow you to upload that workflow you saved and then directly link to a folder of images and to apply that workflow on a batch of images. Okay, so I'm going to go ahead and select this first one. And what you'll see is on the right, you see a window pop up. This window is our Allen cell structure segmenter. If I just have one image open at the moment. If I select what image I want to segment, I'm going to select this example. And then I actually have one channel represented here, but you can have, multi-channel images perhaps, and you can select which channel you'd like to segment. So once I select which channel, then this lights up and you can see this. Now I can scroll down and I can look at this lookup table and just go based on morphology. And I can say, okay, this might look kind of like it. I can zoom in my Napari viewer. Let's just keep looking to see what else we have. In some of these workflows, even though they may look a little similar, there might be something different in the core segmentation algorithm that might be slightly different. And so you can always try out both and see which one you prefer. It's really based on your biological question, what type of segmentation you're trying to achieve. And I can see here, this also looks pretty good. I'm looking here, this is the image on the, whoops, I selected it. The image on the left was the one that was prior to segmentation, and the one on the right was segmentation result. Now, so I selected that one, and this is the Sec61 beta. This is, and my images happens to be the endoplasmic reticulum as well. So we designed this based on our images. But I want to show you this simple workflow first, and then I'm going to show you how you can use it in a different way, and it might not match the same structure, because you might not have Sec61 beta in your cells. So what I want to do first is I'm going to go ahead and just run the default to save time, and then I'll walk you through kind of how you can tweak these steps. So I'm going to go ahead and hit run all. So there's a default parameters set. And when I say default parameters, if you select on each one of these, you'll see there are some different parameters that you can adjust. Okay, I'm going to go ahead and run all. And if I look at my layer list here on the sidebar of Napari, you can see that it's starting to run. Okay, now I'm going to go back up here. Oops, hold on one sec. There you go. Okay, I'm going to pop up this. I'm going to select the eye next to the workflow. One sec. Just taking a little bit to run. So part of the tutorial, you know, the webinar and Zoom, I think it's just taken its time to go. One second. I've got my spinning Apple wheel, if you guys are wondering. That's the one, I think, disadvantage of doing a live webinar is that when you're sharing your screen and trying to run a program, you don't always get the best results. You get some things can slow down a little bit. All right. So Caitlin, I think this is just stalling a little bit for my, what I'm gonna do real quick is just, I'm gonna stop sharing so that it'll run and then come right back, see if that helps. So excuse me real quick. Oh wait, nope, there it is. I didn't have to do it. Okay, so here, I opened up the information tab. And what that is it's the workflow and kind of the steps. And if you're wondering, how do I tweak each step? I've never done this before, you know, and I don't know what to do. So each of these steps, I'm just going to move this over to the left so you can see my Napari window next to it. And you can see there's a pre-processing step, a core algorithm step, and a post-processing step. And what you do is basically you can look at the glossary to see what these mean, and it'll give you suggestions on how to tweak. And really, the pre-processing step prepares that original 3D image for the core segmentation algorithm. And so that beginning step, for example, intensity normalization, will help the segmentation be more robust to different imaging inconsistencies. That might include microscope artifacts or dead cell debris, for example. And what it does is if you have several images where you're looking at the same structure and segmenting the same structure, you can have basically a similar intensity value above the background when you feed this into a core segmentation algorithm. Then there's a smoothing step that is a part of this workflow. And the smoothing step helps reduce the background noise from either the microscope or other sources to help improve the segmentation algorithm. Now, the smoothing, there's 3 types of smoothing, and it really depends on, and this one is edge preserving smoothing, but it really depends on the morphology of the intracellular structure that you're segmenting. And then the core segmentation workflow, this one has just one step here, the filament filter slice by slice. But this step takes the pre-processed 3D image stack and then generates a preliminary binary segmentation. That's input into the final step. And that final step is a size filter step, which can help filter the object by size and then turns into the final segmentation result. Okay, so here, and if you needed more information, you can just scroll down here and get that there. And this is for each workflow, you have this information. So I'm going to close this window, and here is my segmentation result. So you can see this here. I'm just going to zoom in. If I wanted to compare it to my original image, this is what's great about the Napari viewer, or what I like, is that you can click on this, and I am just going to go to my layer controls. I'm going to just make the, oops, not to this one, sorry. Go up to the size filter, to the final step, the final output image. I'm going to come to my layer controls, and I'm going to change the color to let's say a cyan color. And then if I just reduce this, I can kind of see if I zoom in, let me zoom in so you can see a little bit better. I can start to see like how well my segmentation was. Now, of course, you know, this image is exactly the structure that we're using to segment. So it's a really good segmentation by default. And so that's one advantage of, some of the structures. If it really looks like a good morphological match, then you're going to get most likely a really good accurate segmentation out of that. So that's the good thing. So I want to try to, I want to kind of switch gears to give you a different use case where you might not have a structure tagged for that example. So I'm going to go ahead and, so I just want to kind of show you how easy it is to load a picture or load an image and pick a workflow. But now let's actually try something a little bit more difficult. Okay, so I'm going to go back to my layer list. I'm just going to go ahead and, before I do that, one sec. I do want to show that you can save your workflow if you want to apply this to, say, a batch of images, and you can also save your these image outputs. And so all you just do is just file and you save the selected layers. You can, or all layers, depending on what you want to grab. But you can, and I mentioned that you can go through each of these steps and observe what what each step kind of did. And if you tweak right now, the current version of this plugin, you have to tweak. If you tweak one parameter, you have to run the whole thing over. We hope in a future version that we can tweak and then see the result of that tweaking to see how it changes your segmentation result. But for now, it runs all, but it's fairly quick. I know we had a little hiccup with time, but that's just with a lot of things running at once. So it really doesn't take that long. Now, I'm going to just go ahead and I'm going to close this workflow. It's going to say, are you sure? I'm sure. And I'm going to go ahead and load a different image. Okay. So I'm going to go back to, I have some sample images. So here we go. I'm going to go ahead. I'm going to pick, so I got this, this 3D stack from a friend that's doing research in yeast. And I'm going to go ahead and load these. So this might be, in a way, somewhat similar to data you might have, or, different data. But I wanted to highlight this because this isn't our data from the Allen cell collection. It's from a different group. So here I want to just see, okay, what do I have here? Oops. Okay. So here is so these are, let me show you the bright field real quick. Here we go. Oh, I'm not looking at the bright field. Sorry about that. So here is this is the mitochondria, a GFP tag in the mitochondria. And then I am not seeing for one second here. Regardless of the bright field isn't showing up on this, but the mitochondria, oh, here it is. There we go. Okay, I got it. And let me just lay my controls real quick and contrast. Okay. Okay. Well, what I was going to show is that in the mitochondrial GFP channel, we've got there's basically 3 mother yeast. There's one here, and one here. And these are yeast cells, or mother yeast cells with 2 of them have a budding yeast cell. And this one up here has a very small one, and this one has a larger one that is almost completely budded. And then what I want to do is this. So I mentioned this is a mitochondrial GFP yeast cell. And what I want to do is be able to, maybe I want to be able to quantify the volume of mitochondria that's inherited in the daughter cell from the mother cell, and quantify, what's the volume from this. And so we need to segment the mitochondria. Now, if I pick the image layer that I want to segment, I'm going to select my GFP channel. And then I'm going to pick that. And then I'm going to basically select a morphology that looks the best or closest to this. And so what I'm going to do is I'm going to scroll down and I'm going to look for a morphology that looks closest to this. And I just want to get a good view of this here. Okay, so I'm going to look for something that looks kind of like that. And you might think of some of these, might be okay, maybe this one, for example, or, keep scrolling down. You might think this one looks all right, and if I actually showed you the mitochondrial one, which is this one, that doesn't quite match completely. I actually think this one looks better. So let's see what this is. Okay, so this is ST6-Gal1. This is actually the same workflow that we just used for the endoplasmic reticulum. And this just seems like a better morphological match for this image. So I'm going to use this, and I can then, it's the same. So if I look at the workflow for, sorry, this is not for endoplasmic reticulum. Sorry, I just wasn't thinking. ST6, sorry, this is a Golgi workflow. And so the Golgi workflow is different. And so you can see that the steps are different, and the steps here are highlighted here. So you can see that there's a different smoothing step than what was found in the endoplasmic reticulum. And there's a different core segmentation algorithm. And so you can look again at what parameters could be tweaked down here. There's more in this one than in this workflow than in what was found in the endoplasmic reticulum workflow. And so you can use this to guide you into what to change in the steps. So I'm going to go ahead and minimize this window, and I'm going to run this here. There you go. So as this finishes, and it was fairly quick, what I'm going to do first is I'm going to take this output image of the segmentation, and I'm going to just give it a color. I'll try magenta this time. And I'm going to scroll through this here, and let me just go back to my layer list. And I want to look at the original bright field image, and or sorry, not the original fluorescent image, and see what the difference is. I'm going to tweak my opacity to see, so I can kind of see the original image versus the segmentation. So here's the original, my segmentation. If I scroll through this, I start to see, so if you're familiar with your own images, you're going to start to pick up things that you might say, you know what, I know this image isn't as big. Maybe there's some blur in my image that it's capturing as part of the segmentation. And I know from this one, for example, if I scroll here, I'm gonna pick up, and I'm not a yeast expert, but I've been, I do know that from this image that this looks like this might be a little over segmented. So if I look at my yeast again, go back to my layers controls, and I look at my original segmentation. So I'm looking for mitochondria that transfer to a budding yeast that's right here, and then there's the budding yeast cell that's over here. But I see that this looks a little, to me, that looks a little over segmented, maybe. And if I want to calculate the volume of mitochondria, if I take into account this, then I'm going to get an overestimate of that volume. It's going to seem bigger than it really is. So this is where you want to use your biological insight to think about the question you're asking and whether or not you need to tweak your segmentation. And so here I decide, oh, you know what, I think I'm going to change this. So I want to try something different. I'm going to go back to my layer list so you can see what happens. If I change my post-processing step, because I think that this is over segmenting, so I want to change my size filter. You could go here, and then I can change the minimum size. I'm just going to try like 47, and I'm going to try a slice by slice method. Now, if I look at what am I doing? So here, if I go back to my glossary and I look down here, the size filter, it assumes the input is a binary image, and the size filter will remove any objects with a size smaller than the min size. That's an integer value. So I picked 47. It was 10. And then the method, it can be either calculated using the 3D, so it's applied in 3D, or a slice by slice. So I'm going to try changing this just to see what happens. And then I'm going to go ahead and run it. Okay. So I'm going to run all, you're going to see a new result come about. Okay, so now that I've run that, I can look at the output and I can change the controls. So I'm going to change the color here, do cyan this time, and I can look at this one compared to here and my yeast mitochondria. And I can start to see if I see any differences in my segmentation. I can go back and just change my output. And then what I see is that in this new segmentation, do you see these two little dots here that I thought were over segmented? They're now gone. So in my new segmentation, I've got rid of those over segmented pieces. So now my volume of mitochondria that I'll calculate later can potentially be more accurate result in the budding yeast than with the previous segmentation. So let's say I like this segmentation output, and this is for these here, for this top results. You can go through again and look through each step to get more information about each step, but I can save this workflow. If I hit save the workflow, what's going to say is like, do you want to save this? I'll save it as a JSON file and say I save. Yes, I mean, you can name it something, you can save it. And then now if you had a batch of these images, let's say you had yeast images and you had of control and mutant images and you had about 20 of each and you wanted to batch process them all, you could just go up here and now click batch processing. If you click batch processing, it'll bring up a window that'll, this is a new window here, but it'll basically say load your workflow. So I can load that JSON file. I can select which channel. If it was a multi-channel, I can select which channel I wanted to segment, apply the segmentation to, the segmentation workflow to, and then the input directory of the file or folders and the output directory. All the files that are supported include TIFF, CZI, OMI-TIFF. So you can apply these workflow in a batch processing and get the output into an output directory. So that's kind of a brief overview of the Napari plugin for a segmenter with a couple little hiccups, but I think we got them resolved. So it's, this is fairly new, and we know that there might be some issues you run into or some questions you have. And so I want to just go back really quick to our GitHub page. So let me go back here. Whoops, not to that, but to my GitHub. Let's see here. I lost my page here. Let's see. 1 second. My window for, that's not it. Let me stop sharing, get to my actual window. Sorry about that. Let's get to this here. There we go. I got to it. Okay, let me share back. And here we go. Okay. So coming back to this, I just want to go back to a couple things. So one is our GitHub page. So if you're running the Napari Allen cell segmenter and you come up with any issues or things, then you can go to this page here, click on issues, and that will bring you to asking different questions or issues about what's happening with the plugin, and we can try to help you. We respond fairly quickly to this, but also if you have just questions, general questions about the segmenter and how to use, you can come to the Allen Cell discussion forum. You can click on imaging software and code. This will take you to a list of different softwares, but if you just hit segmentation on our forum, you can get to the different questions that have already been asked and learn a little bit more, and you can ask your own. The only thing you have to do is you do have to sign up to ask questions here, because just to make sure that you're not a bot and asking anything random or doing something inappropriate. And so, but it's free to sign up. We will become a community partner on the ImageSC forum, which once we do, you'll also be able to ask your questions here for anything. And then finally, I want to just come back to the GitHub page on our Allen Cell GitHub. So if you were here on our segmenter page, just real quick, you could go to the Allen Cell there, click on that, and this gives you the directory of all our repos in this GitHub account. And so you have these segmentations and you're probably wondering, okay, now what? How do I analyze those results? It does take some computational skill to do the analysis, but we do have an app for that. I mean, we do have something that could help you with that. So we have the AICS feature, which is here. And this is a central code base for cell feature calculations and different applications. And so this can be applied to calculate volumetric data, different measurements, distant measurements, cell volume, things like that. And we'll help you use this if you have any questions and want to utilize this for your own research. And then last but not least, we have before I hand it back over to Caitlin for closing remarks and questions, we do have a list of questions and answers that we've formulated that we'll post up. And that way you can be able to, if you have, there's some common questions that we have, and we'll just be able to share those with you guys, which I think you saw a preview of that as I was trying to open our browser. So we'll get to that a little bit later. So now I'm going to hand it back to Caitlin to give the closing remarks.